Hello, everybody. Hello. Hi. Okay, I see we have now 6 people. We have 38 confirmations. So I have to wait a few minutes. Hello, Don. Hello, Gregory. Hello, Matt. Hello, Robin. Hello, Roland. Hello, Yusuf. Let me wait a few minutes. My name is Andreas Kaczmierczak, and oh, I see here in the top. Normally you can see here the company name, but it's cut today, but I have no time now to correct it. We are the back to CAD technologies. Okay. Okay, let's wait here a few minutes, because if we have 38 confirmations, we will get at least 20 people today. Okay, I see more and more people are coming. Okay, good. This is now time to start our webinar. Again, welcome in my webinar. My name is Andreas Kaczmierczak, and welcome here from Clearwater, Florida. We have a beautiful weather today, 25 degrees, and everybody is here excited here in Clearwater for now spring, what is coming in next 2 weeks. Our spring beginning is at the end of February. Okay, and so this is only a branch here in Clearwater from a German company, Kaczmierczak Software GmbH. We develop in Germany software for over 27 years long. We develop software for AutoCAD add-ons. We develop OnCAD systems. We develop a lot of tools for AutoCAD. I'm a civil engineer. This is my profession. And here in the US, we develop software over 10 years long as back to CAD technologies. Okay, and as you can hear, I'm not a native US guy. I speak native German, and I will try to speak slowly so that you can understand me. Okay, I'm looking here, so you see to the right and to the left, because I have here on the left side your questions, connection with you, everything. If you want to send me any question, then please every time send me it during the webinar. For example, now maybe somebody can send me an info that you can hear and see me. This will be very, very important, because okay, I check here. Okay, who's the first? Who will try to send me now info? You can hear me, because here in my microphone is going well. Okay, now it's not. I'm not sure that you can hear me. Maybe you can see me. Nobody is writing me any info. Hello, Craig, Don, Gregory, Irina, Matt, Nancy, Rachel, Robin, Roland, Sabrina, Joseph. Can you please write me that you can hear and see me? Let me check here now. Questions. That's not good. Okay, thank you, Gregory. Thank you, Nancy. Thank you, Matt. Okay, then I now know that you can speak really. They can speak really to really persons, and then everybody can hear me. Okay, we have now 16 persons. This is very good, so that we start now our webinar now. Okay, good. Again, for everybody who's going a little bit later, my name is Andreas Kaczmierczak, and I'm an owner of the company back to CAD Technologies and of the company Covnerter Software GmbH. And as you can hear, I'm the native German, and I'm now here in Clearwater, Florida, in our American branch with the name back to CAD Technologies. And what I will present you here is a very, very interesting subject. This subject is here, you have now your beautiful Revit, and you can make a beautiful construction, 3D construction, and you know, if you want from scratch, from beginning, this is very, very easy, because you can, so beautiful, it's going very, very fast and beautiful, you can construct your buildings. But what happened if you want to use Revit for the projects, from all projects, for your customers, for projects from scan and everything? And here you will see, you will get a lot of trouble if you will don't prepare the drawings, the underlays before you use in Revit. This is what I want to show you. So let me check here what I have here. For example, this is an old project, and let me check it here. So let me see it here using our internal viewer. So first, what you see here, of course, we don't have here our customers. So first I have to show you. So here, if you will purchase the program Print to CAD 2022 Ultimate, you will get on your desktop Print to CAD 22 Ultimate, okay, and extra CAD Direct LT. This CAD Direct LT is something interesting. This is a CAD system, a real CAD system based on DWG files, but we use this CAD system as a base for our conversions. And for example, here, if you will start the program, I start here the second zone, then you can open here every drawing. For example, I open here an empty drawing. You see, this is a DWG drawing. And now, if you want, you can start the PDF import here. If you push this button, Advanced PDF Import, okay, the program starts here this Print to CAD Ultimate, but this Print to CAD Ultimate is now integrated in this small CAD system. Why you need the CAD system? I will show you because during the conversion, you need a lot of interaction with CAD, because you have to prepare this PDF. Let me show it. So first we checked here the configuration. So the languages interface is English, but first what I'm doing, I'm put here in the configuration that we use the unit millimeter. What is unit millimeter? Unit millimeter, later I will show you how you can work with inch. Why? Because unit millimeter is a base unit of PDF. And look what's happened. For example, I select now here a file like this, okay, and view this file with the help of our internal PDF viewer. This PDF viewer is really made for construction drawings, and you can measure here a distance. Let me measure here this distance here, from here to here. Let me go here, measure distance from here. You can do this with snap. Now let's snap here to this point to see here. Can you see here in this windows? It is 851359 millimeter. What is it? This is a big problem of PDF files. This is only a plot millimeter. Like the unit or the distances you can see in PDF are a simple plot or print units, because PDF is nothing more than only an electronic print. And now, if you are doing nothing, simple converted, okay, I'm converting now. We convert the PDF coordinates 1 to 1 into CAD. Because in PDF, we have no any information about the original unit or original of the scale of the drawing. And look what's happened now. I import here this in the drawing. You see, this is this file after conversion. Yeah, we can see we vectorize here the table. This table was as a raster picture. You can see here in the background the raster pictures here. We did it a lot, but what I wanted to show you here only. Now, if I measure here the distance, this is what you see is this CAD Direct LT, and let me measure this distance. And you can see this is exact the same distance like you saw now in PDF. These are plot millimeter. So what we can do now? Now let me open the new drawing. Okay, new. Okay, let me make again the conversion, and I start the program, and I take the file. That is the same file, but here. Okay, good. What do you have to do now? Yeah, now you have to scale the coordinates. Of course, you can go here on optimization and scale the coordinates, because if you want to use it in Revit, you need the correct coordinates. Here you can scale the coordinates. Look here, under here, scale factor for XYZ coordinates. But the faster and more precise way is, for example, here, scaling of coordinates with a factor. PDF measured distance, it is my 85. This is what I measure in .1359. This is what I measure here in the drawing. And it have to be 4340 millimeter. Now, how I found it out? Simple. If you go here on view input, and I need this drawing in millimeter for Revit, you can see this is German drawing 434 meter. This is 4340 millimeter. Okay. And now you can see I put here in coordinates calibration that measure distance again is, but here the program calculate immediately what is 1, 2. Okay. And now if I start the conversion, okay, I will get correct scaled drawing. Okay, let me put it here now. This is the first step, what you have to do. Okay. So now, if you go here and measure this distance, okay, you will get almost 4340 millimeter. You can see this is really the bad accuracy of this PDF. But look, what's happened. I will try now to scale this absolutely correct. Let I go here on our scale regarding this is, you will find this function here on the scale regarding reference. I scale it. Okay, I'm going here and put here 4340. Okay, let me check now. Okay, so now again distance. Okay, and it seems everything in okay, almost perfect. Okay, let me save now this drawing. Save this drawing, and I will try now to use this drawing in as an underlay in Revit. Okay, let me go here. I save it as example 1. Okay, and now I'm going to Revit, new. Okay, in metric. The next example I will show as I will do it in inch. Okay, I'm not really familiar with inch as a German engineer. Okay, now we are going under here under insert. Okay, insert import CAD, and now I will import this drawing here. So there's a webinar Revit, and here this was this example 1. Okay, okay, but let me check it. Okay, context raster images. Okay, so this is now here our drawing. So let me measure here now. Here, okay, let me measure here. Measure this distance, and now, moment, I have to do something a little bit more, because you see now I can't really see the distances. Why? Because this is something what we have to do with this drawing. Because in PDF files, we have no any information about unit. We have to set now the drawing, this drawing to the correct unit. You are doing here under set unit. And you see, this was an incorrect unit. And I said now the correct unit is millimeter and the decimal. Okay, and I save it again. And you will see now Revit will immediately find here everything the correct the correct letter, hide everything. So this is a very okay. Going here on import CAD, and again example number 1. Okay, and let me check it now this distance. Okay, now on modify measure, and let me measure this distance. Now you see is everything correct. Okay, this is 4340. And now maybe you have the idea you can use this drawing for very fast generation of your walls in Revit. This is a bad idea. Look, if you measure this distance, okay, look, moment, I have to measure it again. Measure, so I can snap the correct point. Look, instead of 3650, you will get 3 millimeter less. Let me check the walls. For example, this wall from here to here. Okay, this 100, but let me check, for example, this wall. Let me check this wall. It have to be 100 millimeter wall measure from here to here. Okay, but let me check here this wall measure from here to here. 96. Right, like you can't use it because the accuracy of this PDF file was too bad. How it happened? How it happened that we have this kind of inaccurate PDF files? So I show you something. Let me check here a lot of samples of PDF. Let me start again here the print to CAD. Okay, and now I will check. I will take here another drawing. So I will select here this drawing here. Revit. I will check here this PDF. View input. Okay, and now I will zoom here this detail. Okay, can you see how it looks? It was really perfect. But the line weight cover here the true shapes of these lines. This is the reason that in our PDF viewer, every time you can go here on wireframe and switch it off. And now look, if you zoom it again, you will get this PDF as wireframe with no line weight. And you can see the precision of this PDF is really good. This is a CAD precision. It means if you want, and if you have tools, you can make a PDF file with astonishing precision, with CAD precision. And if you import now this PDF, or you convert it into CAD and input it into Revit, you can immediately snap the walls and work on it. But let me look here on this PDF. Okay, we check here with this PDF what we also are exactly doing now. Look, so you can see the quality of the PDF if you zoom a detail. Let me zoom this detail. Look, so what's going on? Why is the circle in this shape? This is because this is a PDF made by a very cheap tool. This PDF is made over a printer. And this PDF is made in 300 dpi raster. And what you see here, these are the raster points. Like if you make a PDF in 300 dpi raster, nothing can have a coordinates between it. And this is the reason that you have now this terrible quality of every circle. Look here on this arcs, and you can imagine what kind of terrible coordinates you got. If you have this kind of circles, you will get the same kind of coordinates here. Like every coordinate, every part of this drawing is simple, very inaccurate. And now, if you want to use this drawing, okay, In Revit, you have to adjust this drawing into the correct coordinates, because you have now two possibilities. The one possibility is, yes, you construct here your walls, you snap the points, but every time you check, is this distance correct or not? This is a lot of work, because now maybe you can see the distances, but if you work on this drawing, you will never be sure that you catch a correct distance. You can't really use this PDF or this underlay as something you can construct your Revit. You have to do here something, and this is our new tool. We offer in our program something new. We offer in our program Print to CAD, and this is a part of Print to CAD, the possibility to calibrate the coordinates. But very important is, before you calibrate the coordinates, every time go here and set the correct units and the correct unit types, because we can't find it in PDF. And look what's happened now. Now, simple go here on coordinates calibration, okay? And you can input here the precision, now the tolerance, and simple catch here the points of the dimensions. And if you see, if we offer you here the correct distance, then simple press enter. Now here, moment, I have to check it now here again, coordinate calibration. I will put precision to 0 because we have millimeter, okay, and tolerance to this, and let me check it again, okay. Now we catch from here to here, okay, 100 to here. This to have to be 3, 6, 5, 0. Okay, now we catch this point. It have even 100. You see how inaccurate are the distances. Now we catch this point with 1500. Okay, enter. And now this point, it will the 100. Okay, and you can run here the full dimensions. Okay, so that you can 1500, 150. No, come on. Okay, back. Okay, so you can run here the full drawing. What you can do, because you see, very interesting is that this calibration do not calibrate only this dimension, but this drawing itself too. Let me do it, for example, here from this and this distances. Okay, we go here on again on calibration, precision, and here, and we calibrate. This have to be 100. This to have to be 3500. Okay. Now, okay, I have to do it again. I have now here a little bit problem. Let me measure here this distance here again. Distance from here to here. You see this is 9.6. Can you see it? 9.6. Okay. Okay, let me calibrate it again. No, but I need only the can't really calibrate here because I need 2 hands for it. 100 again. Okay. Okay. Now here. Calibration. Okay. Okay. Now from here to here. 100 to here. 3500. Till here. 100. So let me do it here. The last one here. 3500. And here 100. Okay, let me stop it here because I want to show you. So the calibration of these distances do not change only this distance, but calibrate everything here in the drawing too. Now, if you will check now the distance here from, let me check the now distance for this wall from here to here. Okay, now you can see this is precise 100. And now you can apply the same methods, for example, here on the doors, because you see you don't have any information about the doors. Yeah, there's nothing about the doors, no, but If you have the standard doors, for example, you measure this distance, and you can see now here that this is not a standard doors. It have the 885 millimeter. What are you doing now? Simple, calibrate the coordinates, okay? And now you put here the correct distance, 885, done. Okay, now if you will measure this distance, okay, let's measure this distance. From here to here, moment. I have to check only this correct distance from here to here. So, but you have to look on this X. You can say X distance is exact 885. Okay, so now you can use this, for example, for the walls. If you can see, for example, here, you measure this distance, yeah, okay, and you can see this have to be 100, but it's less. You can correct it. Go here, simple, and correct it. Term here and here to have to be 100. Now you can see, okay, I'll show you something. You can see now here in distance that we have now precise 100. Can you see? Okay. And now it takes maybe 10 or 20 minutes to clean up this drawing, to put the correct distances, but it's very important. So now you can save it as drawing 2, okay? But I didn't prepare here everything, so let me check it here. So how it was looking here. I was doing it today with more samples new. Okay, let me check it now here. Metric, and let me import now here. Okay, sorry. File, save as, again, save drawing 2. Okay, now I'm going here on insert, import CAD drawing some number 2. Okay, so let me check now here the distances. Look, now if you go here and modify and measure something, like we measure this one, you get exact 100. Compare it with this drawing, it was 96. Now if you measure here, okay, this distance here, measure from here to here, look, exact 3500. Let me check what was here before. Distance from here, oh, this was okay, but I think here was not okay. Let me check this distance. You see this was 3496. Now after this adjustment using these dimensions, if you measure here, you will get precise 350. And let me measure the, for example, this distance here. So linear measure from here to here. We have about exact 100. Exact. And now let me measure this doors from here to here. 885. If you will measure now here, let me check it here. I think this was broken. You see, it was 886. Can you see it? And it's now you can see this the using of on this kind, you can correct all coordinates. Now you can use this underlay simple for snapping of your walls in Revit, and you will get a beautiful drawing. This is a big difference. This is a big difference between like correct model or a bad model. And believe me, about 70%, not 75% of PDF files are very inaccurate. But I am going to show us a little bit more. What's happened as a last subject here? What's happened if you will get this kind of drawing from scanner? Select file. Let me take this one. View import. Look, this is a very bad quality scan. If you see if you will see here, this is simple table here. Now, what I'm doing now here, because we use here inches. First, I'm going here to my configuration, switch here to inch. Okay. Start the program again. Now I select this file again. Okay. And I will now simply convert this drawing, but if you want to snap the walls, in a Revit, we need this as an outline. And with conventional software, if you vectorize the software, because this is a raster picture, this is only one huge raster picture you can see here on this rasters, you will never get here an outline, because here the normal programs are not able to see that this is a wall and this is a window. But we have a very special function. I show you here. You have to go now on raster to vector, and for Revit, every time choose the function center line tracing and solid tracing combination. Why? Because with this method, we do not vectorize text, so that you can see every time. If you have something from scanner, you need this text in Revit, because you have to know the number itself. You don't need to apply optical character recognition on it. Of course, you can do it too, but you can use here our solidization. Okay. Now you can go here on very important function, automatic detection and contourization of pixel regions, and here create the hatches on walls as entity solid. This is simple wall detection in this drawing. You will see this was perfect, and now you can use this wall detection for your Revit, because now using raster to vector, we detect where are the walls. You will see this is this is a perfect function for Revit. Okay, now the program is using raster to vector. And okay, let me check now the quality of this drawing. Look, so in the background we have here the original raster picture, and you can see we was able to disconnect this wall from the window. We can see it here too. Okay. And now, if you want, you can separate the walls. I switch the background off. Okay. Now you can see we was able to separate the walls on one layer. Okay. Now we have walls, and now we can snap the walls in. Okay. But if you want, of course, what I'm doing, you can move this dimension, because this is what you need here you'll need it later in Revit. Yeah, go here and I move symbol on the walls. Now I'm going here and switch off everything, because I need only the walls. Okay, look, now we have the walls and the dimensions, and you can see the numbers we do not vectorize, so that you can see it perfect later in Revit. If you will generate the walls here using this raster picture, but you still can't snap it. Why? If you measure here this distance, look, you will get something wild. This is 125. So a very important step is, before you go to Revit, is to set the units. Now we set there the inches. This is correct, but we need the architectural unit types. Let me measure it again. Distance, and you can see distance, and you can see that this is not 10, this is 114 inch. Again, this is only a plot inch. If you want it, you have to scale it. Now we scale it, and this is our reference. Okay, and this reference give us 10 feet. And now I use here, can you see it here in this window? I use now the architectural annotation, and what's going on? If I measure now this distance, you will get here exact 10 feet. Okay, but now if you again measure this distance, you will see this is a mess. 5 316. You can't use it. You can't use this something here in Revit to snap the wall, something like this, because this is a terrible inaccurate. So what we are doing here, you can increase the accuracy using again our function. For example, I'm using this for the horizontal lines. Input precision is 0. Tolerance, let me make now sogar. So make 2 inches. Okay, now snap. Oh, I want to moment. I want to show you something. Look here. Okay, again, calibrate coordinates. Okay, 0. Let me make 2 and snap, and 120, or you can write 10 feet. Okay, snap to it, and here 5 feet 4 inches. Can you see? And here snap, and it will be 14 feet 8 inches. Okay, and you can go through the full drawing. Here is only information we just calibrated. You can go every time here on clear the calibration points. We have no time here to do is everything for the drawing, so that I'm stop it now here and go here on File, Save As, and I will save as a drawing 3. Okay, and now you can see we have the correct unit, we have correct distances, and this is now the perfect underlay for Revit. If you go now here, Imperial, okay, and now we can go to Revit and go here on Insert and Import CAD, and this will be drawing 3, okay, and now you can see. Oh, this is all green. You can really see it, but let me check it now. This is okay. This is now here our drawing, and let me check now here the distances. Measure the distance from here to here, exact 10. Let me measure distance from here to here. Measure from here to here. You can see perfect 10. Perfect. Now measure from here to here. 15, 4. Perfect. Exact like here in the dimensions. So, and now if you, of course, you have to take care for all distances, but you see, we separate you the walls. You can raise it, you can snap it now how you want maybe you will adjust only the distances you really need, and everything else you can use here and snap it here. Like if you go here on architecture wall, and now we can snap here. So okay, but I have to use here the correct wall definitions and everything. You see, big now you have the perfect underlay for your constructions and imagine it was before this simple. Again, we look here on this drawing, select file. It was this terrible quality of scan. You can see here. If you see here, oh my God, this is, I can see there's pixels. There is very low resolution, but we was able to give you a perfect underlay now for your Revit. And very important is here, you see that the numbers are not vectorized, so that if you now want to need the construction, every time you can see here the original text from the raster picture, because this text you see is still rasterized, is not vectorized. These are vectors, and these are the simple solids, what you see here. This is a very important thing. Okay, thank you very much. It was everything what I wanted to show you today, how you can use the program Print to CAD if you want to make a precise underlay for CAD, for Revit. Again, what you have to do after you import the drawing, okay, you have to scale it, and here you will find first the possibility to set the correct unit, This is the possibility to measure distances and here to scale the drawing with global factor. And here you will find the possibility to change the accuracy of the drawing, to make it more accurate using not only the dimensions. This is simple. Give the correct distance and the program take it and move it. Like for example, if you give the correct distance between this and this, we not only change distance between this, but we change this and this too. If you will get, for example, if you give our correct distance between this and this point, we will not skew it, yeah, so, but we correct this distance too, and this distance too. We will correct everything in a drawing. So like this is a special artificial intelligence method for adjustment, and we'll never change any horizontal and vertical line, and we'll never change any right corner. Okay, good. This is everything what I wanted to show you. Thank you very much for your attention. And if you have any question, then please send me the question. Who is the first? Okay. If you have no any question, I can show you only here where you can buy the program. Back to. So what you saw today in our my presentation was the program Print to CAD Ultimate, and this Print to CAD Ultimate contains this CAD Direct LT. So like you don't need this CAD system, you need only Print to CAD Ultimate here. Okay, this Print to CAD Ultimate. And if you go and purchase Print to CAD Ultimate, you can see you pay $229 inclusive CAD Direct LT. Okay. Good. Thank you very much again for your attention. I will finish now our webinar and see you next week the same time. Okay. Thank you. Bye-bye.